All right, so today we're going to study implicit differentiation. Okay. Before we do that, I want to talk about one particular formula we did before. That is a derivative of f of y. Okay. So when you differentiate this first of all you have to differentiate. Well, the chain rule says that this is a chain rule, right? That's actually the chain rule. Then the first part can be simply write f prime and y. The second part derivative is written in this form, okay? Or you can, if you use a prime, then you can also write fy prime and y prime. Okay? But if it's, well, that's confusing. It's easy to be confused. This only, y prime means it's clear to you which variable, what is the input variable here, right? So, so be very careful about the derivative. Now, I think f prime and y means the derivative of f with respect to y, because the y variable is inside there. Otherwise, it's not very clear to us. So we keep writing like this. Okay. So if the derivative so if we differentiate y to the fourth power, then it's y 4 times y to the cube and dy of dx. Okay, because you can differentiate y to the fourth power with respect to y first, and you get this. And you can also the derivative of a square 1 minus y, right? When you want to differentiate this, you have to differentiate this with respect to y first. Okay, if you differentiate this with y first, then well, it's a little bit complicated here, right? So you have to differentiate this with respect to y first, then differential y with respect to x. Okay, so this will be, I hope you know that this is going to be negative of this. Okay, and then dy of dx. So how do you find the derivative of square root of 1 minus y? You have to use the chain rules. All right, so those are the you have to be very careful about which variable you're talking about when you differentiate. Okay. Now, today I'm going to talk about implicit differentiation. First of all, let me look at this problem. It's a circle, right? So every point on the circle is coordinate x and y, but they're related. X squared plus y squared equals 1. So y depends on x depends on y. It's related by this equation. So when x changes, y changes. When y changes, x changes. So y can be viewed as a function of x. X also can be viewed as a function of y. Okay? So y can be viewed as a function of x. Okay? At least locally, right? And if it's point on the upper semicircle, yeah. So if x, you know, right? So if y is positive, then y actually can express in this form. Okay. If y is negative, it's below the x-axis, then y is going to be negative square root of 1 minus x squared. So y indeed is a function of x, and it actually can be given explicitly. But sometimes you cannot use the elementary function to express the dependence of y on x. Right? In this particular case, you can do that. All right, so let's try to find the the slope of the tangent line, tangent line at one particular point. So this could be this first point is 1/2 and the square root of 2. Okay. Yeah, this is indeed a point on the circle. Okay. But you look at this, okay, look at the picture, the slope should be negative, right? So this is point 1/2 square root of 2. How do I find the slope? If you view that piece of the graph as a graph of function, okay, then the slope is going to be the dy of dx when x equals 1/2. Okay. Right? But how do you find the derivative? Well, we already defined the formula. Okay, so okay, y is going to be 1 minus square root of 1 minus x squared. How do you find the derivative? Use a chain rule. Okay, you use a chain rule, and this also can be written in the form like that. So dy over dx is a chain rule. Then you have to differentiate 1/2 1 minus x squared, right? Then you have to differentiate what's inside, right? So the 1 minus x squared. Then you simplify it. You get here. You get a negative 2x divided by 2 is negative x 1 minus x squared to the negative half. So this is a derivative. It's complicated, right, to find the derivative because it's a function, it's the square root of 1 minus x squared. Right? You can also express in the traditional form. So the question is, yeah, there was argument about the quiz problem. Suppose this is a problem. Which one is called simplified version? Okay. Clearly, this is not a simplified version. This one of the last two is okay. Depends on which form you're going to express your answers. Okay. So now the slope is going to be the value of the derivative when x equals 1/2. So be careful to express it. Okay, simplify it. So you will get negative 1 over 2 here, and the square root of 3 over 4. So you can take 2 out. The answer will be negative 1 over square 3. Now, usually we rationalize the denominator, so you get this. So either way, it doesn't matter. But that's traditional. In the denominator, we always write it without the radicals. Okay, so that's a slope. It's negative. It matches with what we see. Okay, so this is answer. But you see that the computation is really pretty complicated. Okay, it's easy to make mistakes. Is there any other way you can solve the problem? Okay, yeah, you can. Okay, you look at all, look at the relationship between x and y. X squared plus y squared equals 1, right? When x changes, y changes. When y changes, x changes. They are related by this equation. So you can view y as a function of x. Okay, so in your mind, you don't need to say that. Okay, you can say that y equals function of x. Okay, I don't need to know the exact formula for that. Okay, then you differentiate both sides with respect to x. Okay, x and y related, but the y is a function of x, and actually you can find it, right? Then the derivative of x squared with respect to x is 2x, right? Now the derivative of y squared with respect to y with respect to x, right? So this is going to be 2y dy dx, and here's it. So you can quickly find the derivative. Good. But it's not expressed in terms of x. But if you want to express it in terms of x, you just change y, right? You can, at the end, you can solve for y if you are able to solve it, okay? But you don't. This is not necessary. You can just leave the x and y in the answer. Now, slope is going to be dy over dx when x equals 1/2. But at the same time, you should also mention what is the possible value y, right? So that's going to be negative 1/2 square root over 2. After you simplify, you get the same answer. Okay, I like this second method. Okay, called implicit differentiation. You don't need to solve y in terms of x, then to find the derivative. You can find the derivative directly. Okay, you just view it. You just view y as a function of x in your mind. You don't need to express it right down. How does y depend on x? Okay. So here's another one. Okay, let's look at the picture here. Okay, so this is a curve, right? The equation for the curve is going to be 1 over x. You can let something slide down from the top to the bottom. Okay. I'm very curious about when x equals 2, y equals 1/2. I'm very curious about the tangent line at that point. Okay, find the slope of the tangent line. Okay, this should be negative. Okay, how do I do that? How can I do that? Well, this equation y equals x, 1 of x, it's the same as x times y equals 1, right? To find the slope, you just needed to find m equals dy dx when x equals 2. But that time when x equals 2, y must be equal to 1/2. Okay. That's all you needed to do, right? But then you view y as a function of x, then you differentiate both sides with respect to x. Okay. Then apply the product rule of the first. It's going to be dx dx y plus x dy of dx equals the derivative of 1, which is 0. As the derivative of x with respect to x is also 1. Then I solve for the derivative. It's going to be negative y over x. Okay, so this is a formula. As long as you know the coordinates of the point on the curve, I can tell the slope at that particular point. Right. So when at the point at x equals 1/2, the same time x equals 2, and y equals 1/2. Okay. So the slope is going to be negative -1/2, and when x is 2. So the answer would be -1/4, but that matches what we see on the picture. Right? Right? So you don't need to solve for y. Of course, if you want to solve for y, it's easy. Y equals 1 1/2. Y equals 1 over x here. Then you differentiate. Sometimes you can solve, sometimes you cannot, right? For example, now this time y equals, wait a minute. Yeah, let's do this first. Find the dy dx when x equals 1. When x equals 1, y is also good. Yeah, y is good. So y is a function for x, and y is a function for x. So you can find the derivative with respect to x. Now you can solve for y, no problem. Yeah. When you solve y, you can solve for y. Y equals square plus y minus 2 equals 0. It's complicated, right? It's a quadratic formula. Y equals 2a minus b plus minus b square. 1 square minus 4ac. 1 minus 4ac. So it's -1 plus minus 1 plus 8x divided by 2x. So complicated. And you have two choices. Which one you need? I think when x equals 1, y should be equal to 1. So when y equals 1, I think you should choose a plus. Okay. So then this is clear that when x equals 1, y is going to be 1. Okay, that piece. Then you have to find the derivative. See, complicated, right? It's harder to find. Hard to find the derivative, right? When x equals 1, y definition, right? And first of all, you have to solve for y. Even you can do that, but still, then you end up with pretty complicated equation. And then you have to simplify it. Okay, it's not easy. So I don't think it's a good idea to do that. Okay, you can do, but it's not necessary. So what I'm going to do is I differentiate both sides with respect to x. But keep in mind, y is a function of x. Okay, so y is f of x. Okay, I don't know this exact formula. I don't need to know that. So the first one is x times y squared. It's product rule. Okay, it's going to be 1 times y squared plus x times 2y dy dx. Okay. Second one is just dy dx, and this is going to be 0. Okay, this applies the product rule to x times y squared. When you differentiate y squared with respect to x, you get 2y, then times dy of dx. Okay. Now those two terms are alike terms, right? So y squared equals 1 plus 2xy. Okay, then you solve for the derivative. Yeah, this is a plus equals 0, then it's negative sign. So this is the most general formula for the derivative. As long as you know the values of x and y, then you get derivative. Okay. So here's x equals 0, right? So slope, no, well, this is slope, but we don't need to talk about slope. Just the derivative of the function. When x equals 1, y equals 1, that's -1 squared plus. Right, the answer is -1. Oh, sorry. Right, so use the implicit differentiation method. You can simplify the computation. The only thing the only way you have to be careful is don't forget, don't forget to put dy derivative y with respect to x when you differentiate function. Okay, so yeah, you should know that's a derivative with respect to x. There are some problems you can solve the function for x, for y, but in some cases you cannot solve it. Okay. For example, like this, x plus y equals x plus y. Yeah, that's minus y. Okay. Now clearly sine pi plus pi equals sine 2 pi equals 0, right? It's going to be pi minus pi. So x equals pi, y equals pi is the point on the graph. Yeah. So right. We want to find the derivative of y with respect to x at that particular point. Okay, how do you do that? Can you find the y in terms of x? No, it's impossible. Okay. Does it have a solution? Yes. So you cannot express it as a solution for y, okay, directly. Even you want to use the inverse of sine function, you still not able to solve for y. But then you can find the derivative easily. So differentiate both sides with respect to x. Okay. When you differentiate sine x, it's become cosine. Then you have to differentiate what's inside, which is x plus y. Okay. All right, now if you want to find the general formula for the derivative, you just solve for the derivative, right? But it's not necessary to do that if you just want to find the value of the derivative at x equals pi. Okay. So first, let's try to solve, right? Find the general formula. Okay, and I have those two terms, right? So cosine x plus y and plus 1 equals the derivative, and equals 1 minus cosine x plus y. Okay. Then you solve for as a derivative. Okay. Then you plug the value for x and y, then you solve the problem. Okay. And when y equals x equals pi, y equals pi, I'm pretty sure this is 1 minus cosine 2 pi, 1 plus cosine 2 pi. Cosine 2 pi is 1, so the numerator is going to be 1 minus 1, 1 plus is 0. But it's better to solve this problem, to find the derivative earlier. Okay, you know that you have a cosine x plus y, right? 1 plus dy over dx equals 1 minus dy over dx, right? This is true in general. You can restrict this equation to the point, okay? At x equals pi, y equals pi. This equation becomes 2 pi here, 1 plus the derivative. Okay, you can let m to be the derivative at a particular point. Then you only have m equals 1 minus m. Okay, you will see that cosine pi is 1, so 1 plus m equals 1m, right? And then 2m equals 0, m is 0. So that would be much quick to find the derivative. Before you find the general formula for the derivative, you restrict the equation to that particular point, so lots of terms are simplified, and then you can quickly find the derivative. All right? Yes. Now, this is a strange equation. I want to find a slope at a particular point. Yeah, find the slope of the tangent line at the point when x is negative square 3 and negative 3 times square 3, then y value is 1. This is indeed a point on the graph. It's difficult to do the computation. Okay, and let me show you how to do that. So when x to the 2 over 3, right? When x equals negative 3 square 3, yeah, let's simplify this. What's the definition of that? I think a negative sign would be gone. Okay. It is going to be negative 3 square 3 1/3 by definition it's square. So negative sign can be taken out when you square it. So it's going to be just 3 square 3. All right, 3 times square 3 is going to be 3 to the 3 over 2. Okay, so when you multiply this out, just equals 3. All right, then 3 plus 1 is going to be 4. Indeed, this is a point on the graph. Now, how do you find the slope? You can solve for y. Yeah, technically you can do that. You can solve for y in terms of x, no problem. But I'm not going to do this way. I just differentiate both sides. All right, so first term is going to get, you're going to get 2 over 3x to the negative 1/3. All right. Now I can quickly get dy over dx equals negative x to the negative 1/3 times y to the 1/3. Okay, it's going to be negative y over 3 to the 1/3 y over x. All right, so at the point when x equals -3 square 3, y equals 1, I get -1, -3 square 3. And you're trying to simplify. And you have negative sign, and positive canceled out. It's 4. Okay. Yeah. So you get 1/3. 4 over 3 times 1. Right. 4 over 2. Sorry. 4 over 2. Yeah, I'm more confused. Okay. So I'm writing some. Yeah. This is let's change it. Yeah. It's going to be 3 over 2. Right, so the answer will be 1/3 to the 1/2. In other words, it's going to be 1/3. 1 over scroll 3. All right, so this is a slope. But if you want to solve y in terms of x, it's become more complicated when you differentiate. Okay, so the picture looks like that. And here's the point. Okay, the slope definitely is positive. All right, I'm going to ask you to do this next one. You are given the equation x squared plus 2xy and plus y squared equals 12. Find the tangent line at the point 2 and 1. 2 and 1 is the point. So what kind of graph does it look like? It is actually the elliptic, but it's ellipse in this form. It is ellipse. It's quadratic equation. So we are looking for the tangent line at this particular point. Okay. 2 and 1. So please go ahead to find it. Yes. You just define the slope of the tangent. You can solve y in terms of x, but that's very complicated. It's quadratic function, but it's very complicated. Then you differentiate y with respect to x, even more complicated. So what you should do is just view y as a function of x, then you differentiate both sides with respect to x. This is a point 2 and Right. So you view locally at that point, you can view y as a function of x. Okay. So you can, yeah, you can, y is a sum function. You don't need to find out. Okay. The slope is going to be the derivative. When x equals 2, y definitely is 1 that time. Okay. So let's find out. Just differentiate both sides with respect to x. So derivative of x squared with respect to x will be 2x. The derivative of 2x x times y with respect to x by the product rule will be y here, 1 times, and x and the dy dx. And the derivative of y squared with respect to x, 2y, dy dx. And here's it. Then you group this two together. I think 2 is gone, just x, y plus x dy dx, and plus y dy dx. All right, so those two terms gives you, let's check, double check. Oh, I see. It's my graph maybe is wrong. Okay, it's okay. Nothing to do with the graph. We're just trying to find out. Okay, I think I'm missing a number at the very beginning of the equation. Okay, so the graph is not necessarily be ellipse. Okay, yeah. But anyway, you solve for y, you find out it's always -1, identical. As long as x plus y is not going to be 0 as the way. Okay, at those points you find the derivative. Okay, so it doesn't matter where it is. Okay, it has a constant slope. Okay, so in particular, at the point when x equals 2, y equals 1, this is 1, then you find this. So the slope is always equal to -1. That means y is a linear function of right. Y is going to be the linear function of x. And actually you get, if you go back to x squared plus 2xy plus y squared equals 12, right? So look at this. This actually is x plus y squared equals 12. So x plus y equals plus minus. Okay. Wait a minute. So the point is not going to be. I think I missed the number here. So 4x. Okay. Otherwise, it's not going to constant. So I'm going to go back because this is not going to be even point on the graph 2 and the 1. Okay. Yeah. Let me change the problem a little bit. So I'm not going to change. Okay. So I'm going to change the problem a little bit. Find the tangent line at I think there's point is 4 here. Otherwise, this is not the graph. Yeah. So this indeed is the point. 2 and the 1 is the point on the graph. Okay. Yeah.
What happens with this is what happens with 2? So I see 2x plus 2 times. When we do the product, we take the derivative, we do the product rule. So So
I take 2 out. Okay, that's okay. This part, the part is I missed the 2 because 4 here. So when x equals 2, 2 squared plus 2 times 2 and plus times y plus 4 times 1 square, this should be 12. Okay, so that's what the point was coordinate 2 and 1 is a point on the graph. So I have 4 here. Then this will be 8. Okay. So when I combine them, and I get 8 here, 8 to 1. Okay. But if I delete 2, and that's actually 4 here. Sorry, not 2, because I already canceled 2.
So are you just dividing those things? That's what it's just a simple.
Hold on. Okay, let me go back. Okay, we are given this. We call the quadratic equation. This quadratic equation draw the graph to determine the ellipse. Okay, and I want to find the tangent line at that particular point, and I double check this is a point on the graph. I did not check that. That's the reason I cannot see it. So I checked that. Plug 2 for x, 1 for y. I got left hand side. I got 12. So this is the point on the graph. And in order to find the slope of the tangent line, you just need to find the derivative y with respect to x. Evaluate at x equals 2. Since this is a point on the graph, the y must be 1. Then you differentiate both sides with respect to x. Right, with respect to x. But in your mind, you view y as a function of x. So when you differentiate y squared with respect to x, you get 2y times the derivative of y with respect to x. So here you have x squared become 2x, but 2xy get 2 squared as a product. Then y squared, 4y squared, you get 8y dy dx. Okay? Then you solve for, and divide both sides by 2. Then you group them together. You get dy or dx equals negative x plus y, x plus 4y. Okay. Then the slope, just evaluate this. You get negative 2 plus 1 and 2 plus 4, right? When x. All right, so it's going to be negative 3 over 6 and then negative 1/2. That is the slope of the, yeah, that's the slope of the tangent line. It's actually negative, so my picture, original picture, is not correct. But I just sketched it out just like ellipse. Maybe I understand that. So the tangent line is in the other direction. The slope is negative. Okay. So the equation for the tangent line will be y minus 1 equals negative 1/2 x minus 2. All right. Yeah, similarly, you can do this problem. X squared and xy and the y cube equals 1. Find this time I want to find the derivative y with respect to x when x equals 1, y equals 0. Yeah, when x equals 1, y 0. So this is indeed a point when the 0 is indeed a point on the graph, okay? And not only that, I want you to find the second derivative of y with respect to x. What does that mean? Now, you know y is a function of x. So the derivative is another function, right? So you can differentiate many times this c1. Of course, you can find the second derivative y with respect to x. Okay. Are you able to solve for y in terms of x? I think yes, you can, but there's no book, no formula you can find from the textbook. Maybe from the mathematical manual for polynomial degree 3. You can express the zeros in terms of the coefficients. Very complicated. Right? I only saw one somewhere. Okay, so the formula you can find it from the internet. Okay, formulas for the roots of a polynomial degree 3 and 4. Okay, for polynomial degree greater than 4, you cannot, in general, okay, you cannot express the roots in terms of the coefficients of the polynomial. This was proved by a young mathematician at the age only 21. All right. So now, let's work out this problem. I'm not trying to solve for y in terms of x. It's impossible, okay? If you're good in algebra, you know you cannot solve for y. If you're not good in algebra, you will solve for y. Give me the wrong expressions. Okay, that's true. So anyway, let's differentiate on both sides with respect to x. Very similar to the above problem, but this time we have to we probably have to do find the second derivative. So how do we do that? We differentiate twice to get second derivative. So first of all, you get 2x, product will give you y plus x dy dx, and 3y squared dy dx equals 0. So that gives you the relationship between the derivative and x and y. You have three quantities right now. X, y, and the derivative y with respect to x. Okay, and you can continue to differentiate, right? 2x plus y and x dy dx plus 3y squared dy dx and it's 0, okay? So the first term is 2 because that's the derivative of 2x with respect to x. Second one is dy dx, great. Then you apply the product rule to this one, and the derivative of x with respect to x is 1. Yeah, this is where it gives you plus. Yeah, it's better like draw a picture so that will not miss any term. Right, this is where second derivative appears, and plus the first term you differentiate 3y squared. It'll be 6y dy dx squared plus y squared because there is another dy there, right? Plus 3y squared d squared dx squared equals 0. Okay, so it's a long line, but you see the second derivative there. Yes, there, right? So this term. You can solve for the second derivative. Get a general formula. Then you evaluate when x equals 1, y equals 0. But I want to solve this in a quick way. So how can I do? I let a to be the derivative y with respect to x when x equals 1 equals 0. B to be the second derivative. All right. Then I restrict this first equation and the second equation at at the point x equals 1, okay? So at the point when x equals 1, y equals 0, the first equation becomes 2, great, plus 0. And when x equals 1, that's just a, plus, y is 0, so 0. So the first equation just a2 plus a. The second equation, you get 2 plus a plus a plus b. The rest of them are 0 because of when y is 0. Okay, so it looks much simpler. So you get a equals -2 and the b equals 0. Okay, b is the second derivative of the function. Is that right? Yeah, double check the work. Yes.
So differentiate both sides after the, on the left-hand side, assuming the right-hand side is like ends up being 0. We should have on the left-hand side an x times the derivative of y with respect to x plus y times the derivative of y with respect to x. That's what I keep doing. I know it's a simple question. I should have brought that earlier, but I keep missing out. I know it is a terrible question. But every time I've done this, I've missed that.
I just first of all, make sure the computation is correct here. When you differentiate, don't miss any terms. You have to apply the product rule and chain rule, blah, blah. Then do not find a general formula for the second derivative because it's very complicated. Okay, in many cases, if I restrict this equation, maybe 2 equations get to the particular point, then lots of terms will be gone. Okay, so let's look at second, all right? And the derivative y with respect to x is just a, 2 plus a plus a. Okay, and then when x equals 1, y equals 0, then the rest of the last 2 terms will be gone. Only the fourth term is b. Okay. So that is yeah, let me check. No, not one. So 2a, when they cancel out, it's negative. It's actually negative. A is going to be, it's positive. Right? Be careful about that. You see, this part is 0, b equals -a. So, yeah, that's right. 5 points, I lost 1 point. The answer is yeah. Don't do too fast. You have to do step by step. Then you will. I know. Then you will get the right answer. Okay. And so let's do the next one. Here's a slightly different form of the equation. If g of x plus x sine g of x is going to be x squared, find the g prime 0. Now, what does that mean? You differentiate both sides with respect to x, okay? If you differentiate both sides with respect to x, yeah, this means the derivative with respect to x. So you get y prime x, and then the product, it's like implicit differentiation. And the derivative x, just 1. And then x sine becomes cosine. Then don't forget you differentiate inside. So if this is correct, then you're almost there. Okay. Only problem is when x equals 0. Okay, when x equals 0, you don't know the sign and the value of g of 0. When x equals 0, this is 0, this is 0, so it's just 0, right? All you have to do is just find g of 0. Okay, what is g of 0? How do you find the g of 0? That's easy. Just plug 0 for x. You will get the first equation, right? G of 0 plus 0 sine g of 0, 0, and clearly g of 0 is going to be 0. So you put it here, then g prime 0 is going to be negative sine 0, which is 0. All right, so here's the question. We have x equals 2y plus sine y. Find the derivative of y with respect to x when x equals 0, y equals 0. Now, first of all, I want to tell you, you can always, the solution exists. You can solve for y in terms of x. Okay. If f of x is going to be 2 plus sine x, okay, then what we're doing here is x equals f of y, right? Then y is going to be the inverse of x. Okay, so actually you're finding the derivative for the inverse function. So my question is, what is the derivative y with respect to x, right? By the formula for the derivative inverse function, this is going to be f prime, okay, right? So that's a formula. Yeah, this is x. Yeah. So I know this is gonna be 0, right? So the derivative when x equals 0, okay, and then that is gonna be f prime, as this is gonna be 0, okay, and f prime is gonna be 2 times cosine. So when it's 0, it's gonna be 1/3. Okay. So this is just use a inverse function. So actually, y depends on x. When you express y in terms of x, you just use the inverse function, right, to express it. Then still you are not able to find the elementary formula for the inverse function. But you can find the derivative, use the derivative inverse using this formula. Then you can still find the derivative, okay, the value at this particular point. But you can also just differentiate both sides with respect to x. You don't need to worry about the inverse function out. Okay, then you will get as 2 dy dx plus cosine y dy dx, and this side is 1. Okay. When x equals 0, y equals 0, it's going to be when x equals 0, y equals 0, it's 2 dy dx at the particular point. And here's cosine 0. And cosine 0 is 1, so I get 3 of this. And finally, dy dx equals 1/3. So you can find the formula for the derivative of the inverse function using implicit differentiation method. Okay, so if y is the inverse function, right? If y is the inverse function, right? This is the same as f of y equals x, right? Okay, let's find the derivative using the differentiation method, implicit differentiation method, right? It's a derivative of 1. And this side is f prime dy at the end. And this side is 1. So the derivative of y with respect to x is going to be 1. Okay, that's it. And what is y? We already know that y is going to be the inverse of the function. Okay, we get the formula. We are familiar with it. This is a simple equation. Only x appears only on the right hand side. All right, so that's all for today's class. Then